All right, and solving problems. These are my favorite ones because we can use proportions. It makes it so much easier. Modeled by proportions. Proportions are going to become your best friend in math because you use it in so many different applications. Oops. Okay, on an architect's blueprints. 1 inch corresponds to 4 feet. You know how I mean by the blueprint? They make a blueprint that's like a model, a small model with the actual size. So that's what it means by that. So 1 inch on the blueprint is really 4 feet in actual size. How long is a wall represented by 4¼ inches on the blueprint? So how many are you thinking, oh, we gotta do this conversion? Nope, no conversion. I'm gonna show you how to do it. And this a quarter was really bad. I probably should put 4.25. We'll probably do that in a second. We're going to use a proportion. Now, when we do a proportion, I'll show you. It's just be easier if I just show you. So I still see someone writing down, so hold on. Watch everybody. All right, so we have 2 units. We have inches and we have feet. If you notice, I have inch, inch, and I have feet. And my answer has to be feet because if I'm talking about inches on the blueprint, it has to correspond to feet in actual. So I'm looking for feet. So I'm looking for feet is what I'm looking for. We do a proportion. Ready? Okay. So what you do is you pick 1 unit to be the numerator and 1 unit to be the denominator. It doesn't matter. So I'm going to pick inches to be my numerator, and I'm going to pick feet to be my denominator. What I mean by that is you're going to make fractions. So 1 inch is to 4 feet, right? 1 inch corresponds to 4 feet. And equal to, I know my other unit is inches. I'm going to put this in decimal form. And what am I looking for? I'm looking for how many feet it is. So 1 inch represents 4 feet. Notice how all my inches are on top, right? All my inches are here. All my feet are here. I'm going to erase that so you can see it. That's how you do a proportion. You put the same units at the top, the different units on the bottom, and then you can solve for the missing part. So I know 1 foot represented 4 feet. I want what 4.25 inches represents in feet, and I don't know what it is. So now we're going to cross multiply. So cross multiply this way. I'll do the math in a second. So we have 4 times 4.25 is equal to cross multiply 1x, which is just x. So I don't even need my 1, just x. So we're just going to multiply. So 4.25 times 4. That would be 20. That'd be 8, 9, 10, 16, 17. I moved my decimal place 2 places, right? Because I have 2 decimal places. So my answer has to be 17. So, and it's a word problem. So word problems rewrite words, right? All right, so the wall would be 17 8 ball. Okay, I got a couple more to do. So if that one's like iffy, we're going to do another one to try and practice. And then we'll get to the next section. 2. An auto mechanic recommends that 5 ounces of, okay, I can never say the word right. I don't know if I spelled it right. I think I did. Isopropyl, okay, I'm going to say it. Alcohol be mixed with a tank full of gas. Tank full of gas, which is 16 gallons. You have to know that because we don't, every tank is different. To increase the octane. So 5 ounce, I see 2 units already. I see ounces, I see gallons, ounces, gallons, right? Okay, at this rate, which means 5 ounces is 16 gallons. At this rate, how many gallons of gas can be treated with an 8 ounce bottle of alcohol? Long one. But 2 things that should that stand out. We have ounces, we have gallons, we have ounces, and we're looking for gallons. So we definitely have a proportion. We have 2 different fractions we can compare. So I'm going to put ounces on top and I'm going to put gallons on the bottom. You can do it opposite way and get the same answer at the end. You can put gallons on top and ounces on the bottom. The biggest thing is that once you decide what's in the numerator and the denominator, you got to keep it the same. So all my ounces need to be on top and all my gallons need to be on the bottom. So 5 ounces of alcohol for 16 gallons of gas equals. Now I want to know how much 8 ounces of alcohol, how much gas I need for 8 ounces. And then we just cross multiply. So my ounces are on top and my gallons on the bottom. So we're going to cross multiply. Oh, notice you can't do the shortcut in this one either because you can't multiply 5 by something to get 8. So the only way to do this one is cross multiply. Hey, 16, let me just write this down. 16 times 8 is 48. 8, 9, 128. I got 128. So 128 is equal to 5x. I'm going to divide by 5, divide by 5. So let's do that. 128 divided by 5. It looks like to me it's going to be a decimal. Let's see. So how many 5 goes in 12? 2. That's 10. 28. How many 5s go with 28? That'd be 5, because that's 25. That means I have 3 left. Okay, here's my decimal. I'm going to bring down my 0, because I think I'm at the end now. So how many 5s in the 30? 6. So my x is going to be 25.6. And always end a word problem with words. 8 ounces of alcohol will treat 25.6 gallons gas, something like that. And I have one more cute little short one to do, and then we'll go on to 6-2. I took longer this than I thought it was going to take. Okay, so word problems always take a long time to write down. Okay, so this is number what, 3? Yeah, 3. 3. I think this one's funny. Okay, at a hot dog eating contest. I can't watch them. Contest. A man ate 21 hot dogs in 6 minutes. Oh, oh. How many minutes would it take him to eat the 35 hot dogs? Assuming it's the same rate of eating hot dogs. Okay, so we have two different things going on, right? We have hot dogs is a unit, and we have minutes. That's what we're comparing, minutes and hot dogs, right? We know we have hot dogs here. I'm looking for minutes. How long would it take him? How many minutes? I'm looking for minutes. So I'm going to put, I'll do it backwards. I'll put hot dogs on top and minutes on the bottom. I do suggest you do this because then you always make sure you're doing the right thing. All right, so hot dogs on top. So 21 hot dogs took 6 minutes. I want to know how much 35 hot dogs, so it stays on top, will eat. How many minutes? So notice all my hot dogs are on top and all my minutes are on the bottom. And once I do that, I can do my cross multiply. So cross multiply. I do it over here real quick. 35 times 6 is 30, 18, 19, 210. So 210 equals 21x. Oh, this one's gonna be nice. Divide both sides by 21. Well, 210 divided by 21, that's just 10 minutes. But again, it's a word problem, so we want to finish it in words. And I know you guys are online, so you really don't have words to type in, but whenever you get into like, you know, a classroom or off of online, you always want to end a word problem with words. Okay, so
Speaking of being online, earlier when you mentioned the developmental 2 class, is that also a Zoom class or does that have to be in class?
it's in class. The one they gave me is in class, but I'm thinking it might be giving one more. There's I should be getting 3 more classes. I just haven't gotten them yet.
I would love to take another math class with you, but my problem is I have to do it online.
Yeah, I know. I appreciate that. But I just want to let you know in case you wanted to come do it in person. There's a really good side of doing it in person. I know it's a pain to go to class and all that. You know, people have busy lives, but you know, I get to sit next to you and help you. And like, you know, there's a different thing. I'm not that professor that like just lectures and leaves. Like I walk around the room and I help people with problems and like, I don't know, it's more personal. That makes sense. But anyway, I appreciate that. But anyway, okay, it will take.
If I took your classes on Tuesday and Thursday for the second developmental, I would totally get out of work to do that.
Thank you. I appreciate that. You know, if it's not developmental, then I'll see you for the next one for intermediate algebra, or just keep looking for me. I'll be there. It will take him 10 minutes to eat 35 hot dogs. Boom. Beautiful. Okay, that's 6-1, which means I probably only get through part of 6-2, but that's all right. I think a lot of it we know already. I think there's some of it as, yeah, okay, we're good. All right, questions before I change my page and start 6-2. Okay, 6-2. Percents, which is probably the new part, decimals, which we know, and fractions. It's sort of like tying them all together. How are percents related to decimals or fractions? You already know decimal fractions, but it's tying it all together. Okay, just to like define a percent, which I think all of you know, a percent means per 100%. So we always measure something out of 100 or even 100. It depends on which way you look at it. It's always measured out of 100 or 100%. I want you to think for these, I want you to think part over whole, because we're going to use proportion. I use proportion for these all the time. I'm definitely going to use proportions for these all the time when we solve. So part over whole. So if I look at 8 out of 100, I'm talking about like a proportion now, not a fraction, right? That means I have 8%. If I have 12 out of 100, I'm talking about percent. That means I have 12%. And if I have something weird like 250 over 100, I really have 250%. Ever hear like people say like, I'm gonna give 110% this class, right? So that would be like 110 over 100, and that's 110%, which is impossible because you only can give 100% of yourself, but it sounds nice. Okay, so percent is used a lot in everyday life, as you already know. I'm sure you see it all the time, percent discount, percent this, percent that, right? All right, okay, so let's tie it to like a problem. Percent problem. Of 100 students, 27 are freshmen. That's it, freshmen. 27 are freshmen. What percent is this? Now notice it's 100, right? So it's like 27 out of 100, which would make I have 27% freshmen. So out of all the student body, 27% of them are freshmen. Now we're going to do ones that are not over 100 in a little bit. So hold that problem. That's just if we already know it's 100. So if you ever can convert a denominator to 100, you can find percent really easy. Sometimes you can't convert it to 100, and that's what we're going to do in a little bit. Okay. Writing percent as decimals. Sort of kind of like backwards. But we did this already. That's why I sort of kind of reviewed. So if I have 13 out of 100, we know that's 13%. I'm going to sneeze all. Oh, sorry. I felt it coming. Okay, but what is it in decimal? Well, if we divide by 100, remember, we move our decimal place how many zeros we're dividing by. So that would be, I take 13, I move it 2 places. That would be 0.13%. I always put, 0.13 in decimal form. We already did that in this last section we did. You divide by 100, divide by 10, you move the decimal place, how many zeros you have. 0.13. So if I want to convert or rewrite 85% as a decimal, I know it's 85 over 100. So it would be 0.85 in decimal form. Since we're always dealing with 100, we're always moving the decimal place 2 places. So I take my 85 and I move it 2 places, and it's going to be 0.85. If I want to know 14%,
Do you always move the decimal to the left?
Yep, left 2 places every time with percent.
Okay.
Yep, left 2 places. So that being said, because that was my segue, I love it. You always get me right when I'm going to say something. Love it. All right. You always move it 2 places to the left. So we don't even have to put it on a fraction. We can just put 0.14. What do you do?
Well,
if
that
you
was
have
like the easy part.
Yeah, I know. What do you do with a number that is actually bigger than 100, like 125%? You still just move it 2 decimal places to the left, and you would have 1.25. That's it. So let's see. I have a whole bunch of practice problems, but I think you got this. Let's not have any weird practice problems. Okay, how if I have this number, 0.46%? I still would move it 2 decimal places to the left. So I would go 1, 2. And that's, don't know why I just did that. Okay, hold on. 1, 2, which means I have to add a 0. So it'd be point or 0 point, 2 zeros and a 4 6. That's my decimal form. So every single time you use a decimal place 2 places to the left. Let me do one more. That's a little odd one too. 600%. Well, I would take my decimal place, which is at the end, and move it 2 places to the left. And my decimal form is just 6. That's where my decimal ended, just 6. Okay, so every time, decimal place, 2 places to the left. That's it. Now you can think of it backwards too. So I don't even have this written down. At least I do. It's coming next, but I'm gonna do it now. Say that I give you, I want to convert from decimal to percent, right? So if I give you 0.25, now instead of moving 2 places to the left, what am I going to do? I'm going to move 2 places to the right. It's backwards. So that would be 25%. So I could go boop, boop. If I give you a decimal 1.75, again, I would move it 2 places to the right because we're going backwards. 1, 2, it'd be 175%. If I give you a decimal of 0.5, I would again move it 2 places to the right. And I actually have to add a 0, and I would get 50%. Any questions on going from percent to decimal or decimal to percent?
Can you do one more of the decimal to percent?
Sure. Let me do a weird one. Okay, let's do this one. 700. Whoops, sorry. 7.12. Okay, I would move it 2 places to the right, and it would be 712%.
So when converting decimal to percent, you move it to the right and then the opposite the other way. Okay.
Exactly. Yeah, exactly. If you can remember that the percent goes to a smaller decimal form, then you remember when you see a smaller decimal form, you're going to make it a bigger form with percent. A couple of practices, you'll have it down. Okay, so I want to come back to one more thing I wanted to do. No, I have a lot more things to do. Hold on. One more thing about, okay, so go back to percent for a minute. So you also will be asked to make them a fraction. So we went decimal we went percent to decimal, decimal to percent. And now we're going to write each percent as a fraction in simplest terms. See how they're all related? We had decimals, we have percents. Now we can write them as fractions. So like this, let's say I have 50%. If I want to go right to a fraction, I'm not doing a decimal. I'm going to go 50 out of 100. They're always going to be over 100. If I divide both of them by 50, I'm going to get 1/2. So every percent is over 100. So whatever number they give you for the percent, you put it over 100 and then you simplify. I love percents. All right, 150%. Well, that would be 150 over 100. I know I can take the 0 out. I can divide both of 15, so I have 15 over 10. I can divide both of them by 5, which would be 15 divided by 5 is 3, 10 divided by 5 is 2. So my fraction would be 3/2.
You were going a little fast for me on number 2. Why did you cross out the zeros?
Yeah, okay. Yeah, okay. So here's a shortcut in math. Ready? I didn't know you didn't know this. Okay, ready? If I do over, I can cross out, and I'll tell you why we do it. It's not because you can cross it out, but you can cross out how many zeros on top to how many zeros on bottom. What you're doing is dividing by 10. So I took a 10, I divide by 10, I divide by 10 again, and then I simplify what's left. So if you had the same amount of zeros on top and bottom, you don't need them. It's just divided by 10. It's a shortcut.
Okay, I understand. Thank you.
You're welcome. So if I have that, I could take 1 0 out because they have 1 0 in each, and my answer would be 6,200. That kind of idea. So you just divide by 10. So we divide by 10, you lose a 0. So I could have gone like this, 150 over 100 divided by 10 first. If I wanted to, that would be 15 over 10, and then I would divide by 5. We can do it all at one time, but that's the idea. So it's a shortcut.
Right. So instead of like writing it all out, yeah. Okay.
Exactly. Yeah, just a shortcut. Exactly. Yeah, I like that. Didn't know you do that. That's awesome. Okay, so if I have, okay, here we go. If I have 1.9%, okay, so that's, we got something we have to do because that's 1.9 over 100. How do I write that as a fraction easily? Well, if I multiply by 10, why would I multiply by 10? Because that means if I multiply by 10, I can make this 19 over 1,000. You want this to be a whole number. You don't want to leave it as a decimal. You can't leave that as a decimal. So what you want to do is move that decimal place or make it 19 by multiplying by 10. Whatever you multiply by top, you want to multiply the bottom by. So this would be my answer. 19 over 1,000, I can't simplify that. That's my reduced fraction. I'll do one just like it again. So you can say it. That one's a little tricky. So let's say I have 2.3%. It'd be 2.3 over 100 because it's percent. But I'd have to multiply both of them by 10 to make the numerator a whole number, which means I have 1,000 on the bottom. And I would simplify if I could, but I can't. Go ahead.
Will you always be multiplying by 10?
No, I was going to do one next. It's not 10. So let's say you're right ahead of me again. Okay, 5. Let's say I have. It's all right. It's good. Let's say I have 5.25%. Actually, I'm going to change it. Make it 27%. Okay, now that would be 5.27 over 100, but I can't have to have a whole number. So this time I have to multiply not by 10, by 100. Why? Because I have to make this one 527, a whole number, which means my bottom denominator is going to be 1 with 4 zeros. 1, 2, 3, 4, 10,000. See how that's different?
She
How I
said
just-
she want to learn something.
What's that? Yeah,
She said she want to learn something.
yeah, go ahead.
No, I was talking about my little cousin. She said she want to learn something.
Oh, she just learned something. Oh, that's cute. How old is she? She's a baby,
She
right?
just turned 9 months today.
Oh, good for her. Good for her. Good to start early. It's awesome. All right, do you see like why I had to multiply by 100 that time, not 10?
Yes.
Yeah, you're basically going to see these more than anything else if you have to do something like that. Awesome. Okay, so, okay, now we're going to write fractions as percent. Right? Fractions as percent. Okay, there's a couple ways to do them. This is probably what we're gonna finish here, but I'll probably come back to it, and then I have, I think, not that much left. This is like the last main section. So I have this. I probably have to add like a little tiny bit. Maybe I'll do a little bit more when we come back before we do the other 2 sections. But do you guys know that you only have 2 more sections to learn and you're done? That's it. Our next class is the last of me teaching. That's it. Okay, so let's try one. Okay, so for example, let me do an example first before we actually do some problems. Say I have a quarter, 1/4. I want to make it a percent. Well, to make it a percent, I need my denominator to equal 100, right? A percent is so much out of 100. So if I have a quarter, how can I make my denominator equal to 100? Well, 4, I can multiply by 25 to get 100. So I would multiply this by 25, and I would have 25 over 100. Now that I got that, remember, don't simplify it because we need 100 to write it as a percent. That means that I would have 25%. So to make a percent, you need 100 in your denominator. You do what you need to do to get 100 in your denominator, and whatever you do to numerator. And once you get it over 100, you know the percent is 25%. The percent is always the number in the numerator once you get 100 in the denominator. Whatever that number is in my numerator, that's my percent. That's the idea. Okay, so let's do it like this one, 3 over 25. I want to make it a percent. No, yeah, percent. So I have to go to a fraction first, and the fraction has to be over 100. So what can I do? Well, I can multiply 25 by 4 to make 100, which means I'm going to multiply 3 by 4, and that would be 12. And then that means that number is my percent. As long as the denominator is 100, that number is your percent, 12%.
So this is kind of like what we were doing earlier, right? Like when we were looking for x and cross multiplying.
Yepper, yepper. We could do cross multiplying too. Yep, exactly. That's why it's tied together. I have that a little bit later on. Actually, we can do one cross multiplying. Let's do that. Now, why would again segue into it? Why would you have to cross multiply? Well, let's say, for instance, I'm gonna make one up. I don't think I have one. Do I have one? No. Yes, I do. All right. Let's say I have 3 over 17. Is there any way to make that 100? Nope. 17 times anything is not going to be 100. So here comes my cross multiplying. This is like my shortcut. Remember my shortcut way? That's what Maddie was referring to. This is my shortcut way, right? You can't always use a shortcut way. Then you have to go to cross multiplying. It all ties together. It's pretty cool. Okay, so 17x is equal to 300. Oops. Divide by 17 to get x by itself. And then I'm going to divide 300 divided by 17. This one I did earlier. It goes on for a little while. So we're going to round this one to the nearest, and it will tell you in a problem if it goes on. We're going to round it to the hundreds. Okay, so there is 117 and 30. And I have 13 left over. Bring down to 0. How many 17s are 130? Let's see. 17 times 6 is 42. Oh yeah, that was bad. That was a bad guess. 7. That was a bad guess as well. 17 times 8. Oh, that's over. Okay, that wasn't a bad guess. Okay, 7, which is 119. If I subtract them, that becomes a 2, that becomes a 10. I have 11. Okay, so I'm going to bring down, now here's my decimal place, right? I'm going to bring down a 0. There's my decimal place. 110, well, I already did it here. That's 6. That's 102. I'm going to do one more decimal place. That's 0, that's 10, that's 8. I'm going to add another 0. Okay, 80. Oh, 17, 5, 6, 7, 8. I think 5's too much. Let me see. I'm doing it in my head. That's 85. Yep, so it's going to be 4. So what's 17 times 4? 28, 4, 5, 68. And yeah, we can keep going forever, but we're rounding to the nearest 10th. So this would be 17.64%. And then it's right at 11:20. So I'm going to stop here, but I'll come back and we'll do a whole bunch more problems. Not a whole bunch, but enough that we can practice. But it's just like we did earlier. It's just either I can do a shortcut way and multiply the denominator by something to make 100, or I'm going to have to cross multiply. Or you can just not worry about it and cross multiply everything. Get your answer. Questions? Anything? It's pretty cool that they're all related. Percent, decimals, fractions, ratios, all the
Two was a
always
weird
related.
one.
Yeah, definitely. Because percents don't have to be a whole number. They can be a decimal percent. So definitely.
But you still
That's-
gotta put it over 100.
No. Now it's like no, now it's just a percent. So when you cross multiply, you already took care of that 100. So that's just your answer. That's your percent. So when you do long division or when you do cross multiplying, you're just finding the percent. You do whatever number you get, that's your percent.
Oh, okay.
We did it over 100 we set it up over 100, but then the answer is a percent. So, okay, here, let me say something. Here, watch. This is my, this is it. This is my part out of 17. This is my whole. This is going to be my part, my percent out of my whole of 100. So see how my part's on top and my whole on the bottom? Same kind of idea we did before with ratios, right? So that's the sort of idea, part of a whole. Okay, that's how you set a mark. Part out of the whole equals part of percent out of the whole percent of 100. And we'll come back and do a whole bunch of them. You can practice more. But that's the end. I have that, and basically that chapter is done. So it won't take that much more to finish that. And then next time we meet next week, we're going to finish everything. We have 2 more sections to do, and that's it. Then we have a test, and then we have final exam review, and then we have final exam. How about that? Feels good, right? Anybody have anything for me? I'm gonna stay on if you have any questions. And if not, I will see you on Tuesday. Great class, guys. Bye.